First, let's talk about systems of equations in general. So a solution to a system of equations is really just the point where two lines are intersecting. But do two lines always have to intersect? Well, sometimes they do, and sometimes they don't. So let's talk about the different cases we could have. First, we could have sort of the simple case. We've got one line going one direction, another line going a different direction, and so they intersect at exactly one point. If this is the case, this means that you have two distinct lines, and the thing that is making these lines distinct and not, say, parallel would be that their slopes are different. Okay, so this means that they have different slopes. If you have two lines with different slopes, then you're guaranteed to have at one point of intersection, exactly one point of intersection. So if this is the case, then we have exactly one solution. If we have two lines that have the same slope, then a couple things can happen. So let's see, if we have the same slope, well, we could have parallel lines. So they have the same slope, but they're never going to touch each other because they're parallel. So if we have the same slope, we could be parallel lines, but it is a possibility that we could have two lines that have the same slope and are exactly the same line. The difference between these two cases is in the first case, where we have two distinct parallel lines, these lines have the same slope, but they have different y-intercepts. In this case, these two lines will never intersect each other, and so this means that there is no solution. In the second case, where we have the same slope and the same y-intercept, this means that we actually have two lines that are identical to each other. So every point on the line is a solution, because this line is entirely spots where the two lines intersect each other. Okay? The points of intersection, there are infinitely many of them because the two lines are the same. So this means that we have infinitely many solutions. So we want to be able to tell, just by looking at a system of equations, how many solutions we're going to have, 1, 0, or infinitely many. And once we know how many solutions we're going to have, we want to be able to determine what those solutions are. So let's see how we can use graphing to help us do that. First, let's try to solve this system of equations by graphing. So let's see. We have negative 2x plus y equals 5, and we have negative 4x plus 2y equals negative 1. What we need to do is first we need to check which case do we have. Are we going to have one solution, no solution, or infinitely many solutions? So all of these depend on knowing the slope. So let's determine the slopes for each of these equations. So for equation 1, if I want to find the slope, I need to solve for y, so I can see what the coefficient is on x. So let's see, if I solve for y, we get y equals positive 2x plus 5. And from equation 2, if we solve for y, well, let's see, we have 2y equals positive 4x minus 1. And so if we divide by 2, this is going to give us y equals 2x minus 1. So the slope for our first equation is positive 2, and we get that from the coefficient on the x. And the slope on the second equation is also positive 2. So this means that we have either parallel lines or lines that are identical. Now, to determine if we have parallel lines or identical lines, we look at the y-intercept. So looking at the y-intercept, the first equation has y-intercept of 5, and the second equation has y-intercept of negative 1. So this means that we have same slope, but different y-intercepts. So we must have two parallel lines. Since we have two parallel lines, that means that our lines are never going to cross each other. They're always going in the same direction at the same speed, so they're never going to intersect with each other. So this tells us that we have parallel lines, and thus there is no solution for our system of equations. Okay. And we figured all of this out without actually doing any substitution or elimination. We didn't actually try to solve for one of the variables, we just checked the slopes and the y-intercepts to give us more information about what was happening in this system. So let's look at another example here. Let's try to solve this system of equations by graphing. So we'll start in the same way that we did before. We'll find the slopes for each and the y-intercepts to see if we have lines that are identical, parallel, or distinct. So let's see, starting with the first equation, if we try to solve for y, we'll get negative 3y equals negative 2x plus 1. And so y would then be 2/3 x minus 1 over 3. Okay. And now working with the second equation, trying to isolate the y so we can figure out slope and y-intercept, we have 15y equals 10x plus 5. Dividing everything by 15, we get y equals 2/3 x. Sorry, this is a minus 5 right here. Minus 5. Let's see, we have 2/3 x minus 5 over 15 is going to be a minus 1 over 3. So now what we see is our two lines are actually identical. So this means that we have the case where our lines are right on top of each other. There are not two distinct lines, they're actually one line. So this means that we have infinitely many solutions. And so we need to be able to come up with a way to describe all those infinitely many solutions. We can't just say that any point is a solution because that's not true. So for example, if we look at the point -1, +1, that may not be a solution because it's off of our graph. So we need to describe all of the points that are actually on the line. And the way to do that is by using what's called a parameter. So we have an equation that describes the line, y equals 2/3 x minus 1 over 3. So our solution set then are all points x and y such that they satisfy that relationship. So we'll write our solution in that way. Solution is going to be all points x and y such that y is equal to 2/3 x minus 1 over 3. And we can write this as a set. Our solution is the set of points x and y such that y is equal to 2/3 x minus 1 over 3. Alternately, you could write your solution as the points x, 2/3 x minus 1 over 3. And that says the same thing. Any point that satisfies that relationship lies on these lines, and so it is a solution to the system of equations.